hypothesis, this is the 5 basic one. So when you graduate from master degree, you must understand the 5 basic one. Okay. For PhD student, okay, you need to know some more complicated method to test your model. Okay. So you should choose, for example, one of at least master one of the type of the analysis. For example, like SEM, you're very expert in SEM, or you can pick out, for example, like a language to specifically learn to test it. Okay, so for the direct effect, it is the right file I have many versions. So okay, so we talked about it last time, right? Anyone still confused about the p-values? Okay, so p-values is everything. It is so the significant in your result, okay? But do not be drive by it so that you do everything to get it significant. Sometimes, it depends on the case. The insignificant hypothesis will give some interesting finding, okay? It depends on the case, of course, but sometimes not significant is better than significant. All right, so last time we already, I think before, around 1 month ago, I already talked about this, the direct effect, right? Anyone still remember this? No. Yeah, that's why today I forced you to do it with me. Otherwise you will forget. Okay, so for the direct effect, for the linear regression, there are 2 things we need to remember. First one is the beta. Okay, and the second one is p-values. Alright, so I found recently I received a very interesting comment that the reviewer, when you write a paper, because you use the italic font, the beta look like this. Okay, so the reviewer think that this one is p-value. For example, like p equal 0.5, maybe like this. And I say that the strength is 0.5 and it's significant, but then he say this is actually the p-value and we have a fight over this. Okay, finally I realized that because I use the italic, so it becomes look like this. Normally it will look like this. Okay, so be careful about this one, especially PhD student. This very funny comment again. All right, so these 2 things is the most important thing in the one hypothesis. The strength is how strong the IV has the effect on DV. Easy to understand, right? What about p-value? What does it mean? Anyone can answer this?
Does the relationship is significant or not?
Okay, you can understand it that way, but honestly, what the real meaning of it? Yeah, it's so whether this is significant or not. But what is the meaning behind that? Okay, so look at it. P-values. Okay, so let's say p-value starting from 1. Okay, let's say if 100 times something happened 100 times. Okay, so it happened like 95 out of 100 times. The same prediction. How much p-value is it? How much chance it will happen? Like 95%, right? So we will reverse it. It will be 0.05 possibility of things will not happen like we expect. Okay. So if we go higher, let's say 99 on 100, so the percentage will be 0.01, right? And if it happened like 99.99999 on 100, so the p-value will be 0.00001 or something like that. Okay, so the smaller the p-value, the better, because that means the higher chance you will get the situation happen like what you expect. Understand? So the p-value smaller, that means the higher chance the situation you predict will happen exactly like you predict.
Probability.
Hmm?
Probability.
Right, it's probability. But if we say probability, maybe the other don't know what that really means. Okay, because some of you maybe didn't take the statistics class. Okay, so in simple terms, that the lower, the higher the chance, the relationship will happen like we expected. Okay, so 2 things. How often it happens, p-values, you see. How often the thing will happen like this Okay, the more closer to 100%, that means absolutely the better. Second, how strong is it? If it happens, then how strong is it? Okay, normally p-value will be more important than the beta, normally, but in some case, when we try to compare the effect, it also come into the concern. All right. So this is the theory about the direct effect using the regression. So this is the table. How you report it? This is very simple table. Only one IV and one DV. Okay. So in the model one, this is the what we don't care about because this is the control variable effect on the DV. Okay. So you see this is a box of IV here. We left it empty. That means we didn't enter it into the formula. Sometimes when you read the old paper, we say that we adding something into the consideration, or we adding something into the equation. Okay, that means this means we didn't include HPWS in our equation when you calculate regression. Okay, so this one is what we care about. It's including the effect of control variable and also the IV here. Okay. I already explained it last time, but I will say it again. These numbers and this number are two different things. Okay? This number p-value here is the p-value of the whole model 2. Okay? Just like this. 0.6 is the p-value of the whole model 1. Okay? When everything is considered together, this is the p-value. Okay? How often it will happen this way? It's like 100%, almost 100% the thing will happen this way if we consider all of them together. Okay, so for the HPWS here, this one, it comes from the order number I will show you later. Okay, this shows the strength of the IV on the DV alone. This one shows the effect of the whole control variable plus IV on the DV. This one only shows the effect of IV on DV. See the difference? Okay, so here, look at this gender here. They actually also have p-value, but because their p-value is higher than 0.1, so I didn't put anything here, showing that this is not significant. Each of them will have different p-value, 1, 2, 3, 4. We will have totally 4 p-value for 4 control variable and IV here. And everything together, we have another p-values. All right, yes?
I don't really understand what is HPWS.
It's just the name of the construct. You don't need to care about it right now. It's just a name.
That's just like gender.
This one is like the HR system when you apply into the company. Whether it will make the employee become more proactive if you apply some certain type of HR practice.
So that's just the p-values value, just like H has a p-value, HPWS has a p-value.
Right. Each of them, all of them have a p-value. Okay, I will show it later. When we don't write anything here, okay, that means they didn't significant. They didn't really, the p-value is higher than 0. In my standard, it's higher than 0.05. But it's some flexible standard, they will accept 0.01. Okay. So this is the combination of many direct effects. This one is single direct effect. You see that? One IV, one DV. See? One DV. So this one I combine many different IV and many different DV. Okay? You can use almost the same table for the SEM math analysis later. Okay, so let's practice. Okay, you can start recording.